Hey kids, welcome to section 6.3, logarithms and logarithmic functions. Today you're going to learn how to evaluate logarithmic expressions and how to graph logarithmic functions. So let's talk about what a logarithm is. Think back to when we learned about exponential functions, y equals 2 to the x. You can find its inverse by switching the x and the y. And so the inverse would be x equals 2 to the y. Well, the inverse is 2 to the y, but in general, the inverse y equals b to the x. The inverse is x equals b to the y. The variable y, that part in the exponent, is called the logarithm of x. The way that you read a logarithm of x is y equals log base b of x. And so because the y value is now the logarithm, we have this new function called a logarithmic function. The definition of logarithms can be used to express logarithms in exponential form. And you can also put exponents into logarithmic form. So basically, you can switch back and forth between logarithms and exponents. So if you have log base b of x equals y, you can change it to an exponential function by taking the base b and still making it the base. But now the answer is the exponent, and the x value is now the equal sign. So for instance, if you have log base 3 of 27 equals y, then you can write 3 to the y equals 27. And so now you can figure out, oh, y is 3 because 3 times 3 times 3 is 27. So logarithms are helpful when finding powers and exponents of different functions or values. All right, so first let's just rewrite something in logarithmic to exponential form, and then we'll go exponential to logarithmic. So to write letter A in exponential form, you're going to take the base 4, because this says log base 4 of 16 equals 2. So you're going to take the base 4, you're going to put it to the second power, and you're going to set it equal to 16. And that makes a true statement. 4 squared equals 16. Letter B, log base 3 of 729 equals 6. You take the base 3, you raise it to the sixth power, and it equals 729. And in fact, 3 to the sixth power is 729. If you look at letter C, log base 16 of 4 equals 1/2. Exponential form would be 16 to the 1/2 power equals 4. This is also a true statement because remember, 16 to the 1/2 power means the square root of 16 to the first, and the square root of 16 is 4. Letter D, log base 4 of 1/16 equals -2. You can rewrite it in exponential form. 4 to the -2 power equals 1/16. Remember, 4 to the -2 means 1 over 4 to the +2, which is how you get 1/16. So these are our exponential functions. All right, so now let's take something in exponential form and put it into logarithmic form. So 4 cubed equals 64. So the base 4 is going to be the base still, so log base 4. Then we take the power, and that goes next to it, equals 3. So 4 to the third power equals 64. Log base 4 of 64 equals 3. In letter B, 125 to the 1/3 power equals 5. Remember, 1/3 power means cube root, and the cube root of 125 is 5, so it makes sense. So we take the base 125, and it still is the base, so log base 125. Then we put the equals to number 5, and it equals the power 1/3. If we look at letter C, 9 to the -1 equals 1/9. We do log base 9 of 1/9, and that equals -1. Letter D, 2 to the 8th power equals 256. The base 2 stays the base, so log base 2 of 256 equals 8. So you're going to be, you need to be really good at changing stuff from exponential to logarithmic and back again, as that's how you're going to solve equations involving exponents. All right, so let's actually simplify some expressions. So log base 16 of 4. Let's pretend it equals x. So what we're really doing is doing 16 to the x power equals 4. So what do you have to do to 16 to get to 4? You have to square root it. And square rooting it is the fraction 1/2. All right, if we look at letter B, let's pretend it equals x. So 3 to the x equals 81. So what power of 3 equals 81? That would be 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. If we look at letter C, let's pretend it equals x. 1/2 to the x power equals 256. All right, so let's think about this as x to, or 2 to what power is 256? And so if you do 2 to the 8th, you get 256. So since 2 to the 8th is 256, then 1 over 2 to the 8th. No, my bad. So if I start with a fraction, then I could do 2 to the negative 8. No, sorry, my brain. If I switch this as 1/2, then I'm going to put it to the negative 8 power. That's what I wanted, equals 256. So my x value is negative 8. So notice that if it goes from a fraction to a whole number, that there was a negative power involved. If it goes from a big number to a small number, you have a fraction involved. A small number to a big number, you have a regular value involved. And this one is kind of funky. This one says if we set it equal to x, 1/6 to what power equals 1 over 216. So a fraction is staying a fraction, so I just need a value of x. So think about how 6 can be taken to a power and get 216. Well, 6 to the 3rd is 216, so x equals 3. If I look at letter E, pretend it equals x, change it to exponential form, 13 to the x power equals 169. Well, 13 squared equals 169, so x equals 2. If I look at letter F, set it equal to x, negative 6 to the x power equals 1. Well, the only value that I can raise a number to and set it equal to 1 is 0. Anything to the 0 power is 1. Okay, so that's how you evaluate logarithmic expressions. Let's talk about how we can graph logarithmic functions. So we can graph and transform them just like all the other functions. A logarithmic function looks similar to an exponential function, but maybe one that is tilted on its side. We don't have a horizontal asymptote anymore. We now have a vertical asymptote. And so the vertical asymptote is now going to be right there or right here. The domain now is restricted to 0 to infinity versus the range is all real numbers. We still have an asymptote, this time though it's vertical. We can still move them right, left, up, or down. We can still reflect them. We can still stretch and compress vertically. Notice these different order pairs as well. 1, 0, B1, and 1 over B negative 1. We're going to use those when we graph. So let's see how we graph them. So letter A, f of x equals 2 log base 3 of x minus 2. The first thing we want to do is figure out what values to use in my table. Now, the values that I want to use in my table are kind of weird to find, but the first one is you want to take whatever is in the parentheses and set it equal to 1. X minus 2 equals 1. Then you want to set whatever's in the parentheses equal to whatever the base is, which is 3. We'll see why we're going to do this in a second. So always take the parentheses and set it equal to 1, and take the parentheses and set it equal to 3, or whatever that base is. So now this gives me an x equals 3 and an x equals 5. Those are the values I want to plug in, and you'll see why in a second. So if I plug in 3, 3 minus 2 is 1. Log base 3 of 1 is 0, times 2 is 0. A couple of things to remember. If you have log base b of 1, the answer is always 0. If you have log base b of b, the answer is always 1. So by using these two properties, I can make the graphing a lot quicker. If I plug in 5, 5 minus 2 is 3. Log base 3 of 3 is 1, times 2 is 2. I also have a vertical asymptote at 2, because the vertical asymptote comes from whatever the parenthesis thing is. X minus 2 equals 0, so x equals 2. So I can draw my vertical asymptote, and then I can plot my points 3, 0, and 5, 2. This is going to make my picture get really close to x equals 2, and then get bigger. It doesn't say domain and range, but we should probably practice finding that. My domain is restricted to 2 and above, so from 2 to infinity. My range is anything, so negative infinity to positive infinity. All right, if we look at letter B, f of x equals negative log base 1/2 of x plus 1 minus 5. Well, I can make my table. Remember, I want the stuff in the parentheses to be equal to 0, or to be equal to 1. So x plus 1 equals 1. And I want the stuff in the parentheses equal to the base. So that's going to give me an x of 0 and an x of negative 1/2. If I plug in 0, I get 0 plus 1 is 1. Log base 1/2 of 1 is 0. Attach a negative is 0. Minus 5 is negative 5. If I plug in negative 1/2, negative 1/2 plus 1 is 1/2. Log base 1/2 of 1/2 is 1. Attach a negative is negative 1. Minus 5 gives you negative 6. So let's draw, don't forget the asymptote. The asymptote is what makes the parentheses stuff equal to 0. So that's going to be x equals negative 1. So we have an asymptote. Okay, we got two ordered pairs, 0, negative 5, and negative 1/2, negative 6. So if I draw my graph, it's going to kind of look like that. I can look at domain and range. My domain is restricted from negative 1 and above, so my domain is negative 1 to infinity. My range is going to be everything, so negative infinity to positive infinity. All right, so again, to find those ordered pairs in the table, the x values come from setting the parentheses equal to 1 and setting the parentheses equal to the base. And that's because we can use these properties up here to graph. All right, let's take a look at a word problem. The pH of a solution can be found using the formula pH equals negative log of H plus, where H to the plus stands for the concentration of hydrogen ions in moles. What is the pH of a solution to the nearest hundredth when H to the H plus is 1.356 times 10 to the negative seventh? So the pH of a solution is found by doing negative log, and H plus is the hydrogen atoms. So that's 1.356 times 10 to the negative seventh. If I type this negative log of 1.356 times 10 to the negative seventh in my calculator and round to the nearest hundredth, I get a pH of 6.87. All right, letter B. The decibel level L of a sound is determined by the formula L equals 10 times log base 10 of I over M. Find I in terms of M for a noise with a decibel level of 120. Well, decibel level is L. So I have 120 equals 10 log base 10 of I over M. So I can divide both sides by 10. So that gives me 12 equals log base 10 of I over M. I can change that to an exponential function by doing 10 to the 12th equals I over M. And if I want to write I in terms of M, I need to get the I alone. So multiply both sides by M. And you get I equals 10 to the 12th times M. All right, so that's how you deal with logarithmic expressions and graph logarithmic functions. If you guys have any questions, please let me know. And as always, keep calm and keep trucking.